I am Dr. Ananta AMB, Professor and Head of Civil Engineering Department, SVIT, Bangalore. Today we will see one problem on deflection by conjugate beam method. So it is of Module 3 of Subject Analysis of Determinate Structures. Determine slope and deflection at points B and C of a cantilever beam shown by conjugate beam method. So this is the cantilever beam. Here one point load is there, then UDL is there, 10 kN per meter. Point load is 15 kN. Distances are given 2 meter, 2 meter. Again flexural rigidity is here 2I, here I. Now first aim is we have to calculate the bending moment. Bending moment at free and B is 0, already we know. Bending moment at C is, see there UDL is there, that will create bending moment. So what is the amount of bending moment by this UDL is, total load of the UDL is 10 into 2 is 20. It will act at the CG. It will act at the CG of the UDL. Therefore, total load is 10 into 2, here 20 kilonewton. So the moment is, it is acting here. Therefore, the perpendicular distance from here to here, it is 1 meter, because total UDL is 2 meter. Center is at 1 meter. Therefore, it is 10 into 2 into 1. It will create clockwise. To the right, clockwise is negative. Therefore, 10 into 2 into 2 by 2 means 1 meter. 2 by 2, it is minus 20 kilonewton meter. Next, we have to calculate bending moment at A. I have to consider full portion. Therefore, due to this UDL is, the UDL is acting here only. 10 into 2, it is at the CG. It will create clockwise moment about A. The distance is from here to 1 plus 2 is 3. Therefore, it is 10 into 2 into 3 meter. 10 into 2 into 1 plus 2, 3 meter. Next, the moment due to this 15 kilonewton load is clockwise is minus to the right. 15 into 2, it is 30. Total it is minus 90 kilonewton meter. Now I have to draw the bending moment diagram. This is the zero line, reference line. Below values are minus, all values are minus. This is at B is 20, B is 0, at C is 20, at A is 90 kilonewton meter. This is BMD. For conjugate beam method, we want M over EI diagram. M over EI diagram. Now see, from here to here, the flexural rigidity is I, AB, then no change. Therefore, it is 20 by EI only. 20 by EI only. But for portion A to C, it is 2I. We have to divide all these values by 2. This value and this value by 2. If I divide this 20 by EI by 2, it becomes 10 by EI. Again, if I divide this 90 by 2EI, it is 45 by EI. Then am I joining these points. Then for calculation purpose, I am dividing this into a rectangle. Again, this is a triangle. And this variation is parabola. Variation of this is parabola. Why? Because it is UDL. Variation and the load is UDL. If UDL is there, the variation of the bending moment diagram is parabola. Therefore, this is also a parabola. This is called M over EI diagram. See, then we have to draw conjugate beam. Conjugate beam. In conjugate beam, fixed end becomes free end. Free end becomes fixed end. See, I will show this. See, free end becomes fixed end. Fixed end becomes free end. Now this is the beam. A dash, B dash I am marking here. This point is C dash. Now I am taking this M over EI as the diagram as the load over this beam. Then I am treating it as a load for the conjugate beam. Now this is the rectangle. See, this values we know 10 by EI. Therefore this also 10 by EI. Total is 45 by EI. Therefore remaining is 35 by EI. Then I marked all the CG values. See, for the parabola I given, see, the CG is at a distance from here 3/4 of 2. 3/4 of 2. From here 1/4 of 2. Triangle already we know, from the apex it is 2/3 of 2. 2/3 of 2. And for the rectangle it is at the center. 2 meter means 1 meter, 1 meter. I marked all the CG values. So this is called conjugate beam. Conjugate beam. Now I have to calculate slope at C. Slope at C. The slope at C in the original beam should be equal to shear force at C dash in the conjugate beam. Shear force at C dash in the conjugate beam. Therefore, theta C is shear force means I have to consider this left portion. All these downward, upward loads are there. If it is bending moment diagram is downward, I am treating all the loads are acting upward. So this triangular load is upward. Therefore, it is 2 into 10 by EI. 2 into 10 by EI. Plus this load half into 2 into 35 by EI. To the left of C only two areas are there, therefore it is the slope at C is 55 by EI. Now I have to calculate the deflection at point C. Deflection at point C in the given beam should be equal to bending moment at C dash in the conjugate beam. C dash in the conjugate beam. Bending moment, this means area into its CG distance plus area of this into its CG distance. Therefore it is, what is the area? 2 into 10 by EI into its CG distance is 1 meter. 2 into 10 by EI into its CG distance is 1 meter plus area is half into base into height, half into 2 into 35 by EI into its CG distance from C dash is 2/3 of 2, 2/3 of 2 CG distance. We got deflection at C is 66.6 by EI. Now I have to calculate slope at B. Slope at B, here slope. The slope at B in the given beam should be equal to shear force at B dash in the conjugate beam. See, if you take B dash, if we are moving from right to left to right, this area, this area, this area we have to consider. Therefore theta B should be equal to, what is the area of this? 2 into 10 by EI, 2 into 10 by EI plus half into 2 into 35 by EI, half into 2 into 35 by EI plus area of this parabola is 1/3 of B into H, 1/3 of 2 into 20 by EI, 1/3 of 2 into 20 by EI. I got it is 68.33 by EI. Now I have to calculate the deflection at point B should be equal to bending moment at B dash in the conjugate beam. How to calculate bending moment? Area of this into its CG distance from B plus area of this into its CG distance from B plus area of this into its CG distance from B. All the CG distance I marked. Therefore deflection at B in the original beam should be equal to bending moment at B dash in the conjugate beam. Deflection at B in the given beam should be equal to bending moment at B dash in conjugate beam. Therefore what is the moment of first area? First area is 2 into 10 by EI into its CG distance is 1 plus 2, it is 3. See, 2 into 10 by EI into its CG distance 1 plus 2 plus second area is this, half into 2 into 35 by EI into its CG distance from B is, it is 2 plus 2/3 of 2, 2/3 of 2. Therefore half into 2 into 35 by EI into 2 plus 2/3 of 2. Then last area is this parabola. It is area is 1/3 of B into H, 1/3 of 2 into 20 by EI into its CG distance is 3/4 of 2. So therefore here it is 1/3 of 2 into 20 by EI into 3/4 of 2. I got a deflection delta B equal to 196.66 by EI.